Welcome again. Let's talk a bit more about natural numbers. So we know natural numbers start from 1, 2, 3, 4, and so on. Let's talk about one digit numbers. So we know that 9 is the largest one digit number and 1 is the smallest one digit number. We are talking about natural numbers, and that's why I have excluded 0 from our discussion for now. How many one digit numbers are there? We can count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 one digit numbers. Now, can we also count how many two digit numbers are there? So, what are the two digit numbers? The smallest two digit number is 10, right after 9, 11, 12, so on up to 98, 99. And after 99, we will have 100, which is a three digit number. So from 10 to 99, how many numbers are there? Now, unlike one digit number, it's not really that easy for me to count them, right? Let's try to build an equation. Okay, so let's build an equation. So what I have drawn here is a number line. We all know the number line. 0, on this side we have the negative numbers. We will worry about them later. And this side we have the positive numbers. Now this is the smallest one digit number. This is the largest one digit number. Now what I want is this. How many numbers are here from this place to this place? I can count it 1, 2, 3, 4, 5, 6, 7, 8, 9. It's easier to count with one digit numbers. Now can I do some mathematical operation to find this out? Let's look at subtraction. What happens when I do 9 minus 1? What happens? So when I do 9 minus 1, what is the value? 8. Why is it? Why is it that way? So this is number line 9. This is number line 1. When I subtract 1 from 9, I get this. And this is 8. 1, 2, 3, 4, 5, 6, 7, 8. The difference, okay? The difference of 9 when 1 is removed from it, 8 is left because 8 digits are left. 1, 2, 3, 4, 5, 6, 7, 8. 8 is left. If I add 1 to this, it gives me 9. So what I'm doing is that don't remove 1, add it back. Let's take another example. Let's take an example of how many digits are there between 5 and 8. I want to find 5 and 8. So number of digits is 1, 2, 3, 4. I counted it, 4. Now let's apply the same formula to see if we can find out using the formula. So 8 minus 5. 8 minus 5. So 5 is removed. What is left? 3 is left. 1, 2, 3. 8 minus 5 is equal to 3. We know that. Plus 1 equal to, put 5 back, equal to 4. So this formula we can use. The largest digit minus the smallest digit plus 1 will give me how many digits, how many numbers are there for that digit. Revise it please. So continuing with that example and that equation, let's find out how many two-digit numbers are there. So the largest two-digit number is 99. minus smallest two digit number is 10. How much is this? 89 plus 1 equal to 90. So we had 9 one digit numbers, 90 two digit numbers. Let's see if there is a pattern here. Largest three digit number, smallest three digit number plus 1 is equal to 900. So you see a pattern. So there are 9 one digit numbers, 92 digit numbers, 900 three digit numbers. How many four digit numbers? 9000, and so on. So we see a pattern, right? So this is how we can calculate how many two digit, three digit numbers are there by taking the largest number, subtract from it the smallest number, and add 1. In a separate video, we will also talk about brackets. In this particular case, it wasn't really that necessary to add the bracket, but I still added it for clarity. So what we are saying is that subtract the smallest number from the largest number and then add 1 to it. So that is the purpose of brackets. How and in what order you want to do a calculation. We will talk more about brackets in a different video. The question that you should ask me is, why are we adding plus 1 to that equation? Is it just because I said so? Never take that as an answer. Always understand the equation, any theorem, any formula in mathematics and science. Always get to the details. So, what was the problem again? How many numbers are there from 5 to 8? Important thing is both are included, meaning 5 is also included in my counting, 8 is also included in my counting. So I did a simple counting 1, 2, 3, 4 because visually I can tell it's a small example to prove an equation. Now then we said let's do a subtraction. 8 minus 5, that gives me 3, which is this line, and it has 3 numbers 1, 2, 3. Actual, how many numbers are there? 4. 1, 2, 3, 4. By subtraction I am getting 3. 1, 2, 3. What is the difference? Ta ta ta. 1. So if I add 1 here, it becomes equal, and that's how we got the number 1 to add to our equation. Now let's solve some problems. What do you think is the smallest 5-digit number which has at least 3 digits, with 3 digits? Okay, so this is a problem. So let's start. What is the smallest 5-digit number? We know that, right? 1000. It has to start with 1. It cannot start with 0 because if I write like this, it's 1 because the place value of 0 is 0, 0 is 0, 0 is 0, 0 is 0, and place value of 1 is 1. So effectively this number is nothing but 1. So the smallest 5-digit number is ones, tens, 100, 1000, 10,000, 10,000. We already see that there are 2 digits used here, 1, 0. Now I need to use another digit to solve this problem because I need to find the smallest number with 3 digits. 2 digits are already used. Because I have to find the smallest number, I will naturally use the smallest digit. What is the smallest digit that I have not used? 2. And where should I use it? Should I use it here or should I use it here? Which has the smallest place value? Definitely ones place. So I will use 2 here. So 10,002 is the smallest 5-digit number which uses 3 digits. Now let's solve another problem. What is the largest 7-digit number with minimum with 3 digits? So the keyword here is largest. And again, like previous case, we will start with the largest 7-digit number. Easy peasy. What is the largest 7-digit number? All places occupied by 9, because 9 is the largest digit. So what is this number? 9,999,999. So everything is a single digit. I have to use 2 more digits. What other digits I will use? Will I use 0, 1, 2, or will I use 7, 8? The answer lies in this keyword, largest. So definitely I am going to use the larger digits. Where will I use them? Should I use them here, or should I use them here, here? Where should I use them? If I use 8 or 7 here, will its place value, it will definitely be lesser than the place value for 9, right? So I need to make sure that I am using somewhere here in ones place or tens place, so that the reduction is least, because I want to find the largest number. In other case, let's take, since this is the largest 7-digit number, what is the number that comes just before it? So if I subtract 1, 9, 9, 9, 9, 9, 9, 8. Perfect. Now if I subtract one more, it will become 7, but it still doesn't solve my problem. It is still using only 2 digits. So I cannot subtract 2. So 9,999,999 998. This uses 2 digits, but I have to find the largest number with 3 digits. So where should I use 7? Should I use 7 here, or should I use 7 here? Or the question should be, should I use 8 here, or should I use 8 here? Which one will have a larger value? Let's look at both the examples. Let's write 87 and 9,999,978. Which one is bigger? 1 or 2? It's easier to figure out, right? That this is bigger because the place value for 8 in tens place is more than the place value of 7 in tens place. So this is 87. This is 78. So 87 comes after 78. So this is the answer. So like this, you can find and solve problems which require you to mention some 5-digit number or 9-digit number, largest, smallest, with 3 digits, with 4 digits, using this method. Let's do one more example to make it clearer. Let's say I want to find a 10-digit number, the largest 10-digit number with 10 different digits. Okay, so we will use the same approach like last time. The bigger digits should go into bigger place values, and that way we will have the larger number. So we will start with 1, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So this is my largest 10-digit number with 10 different digits, all 10 digits. What is it? This is 9,876,000,000 543,210. Pause the video and try and see if there is any number which is bigger than this and uses all 10 digits. Now, what would be the smallest 10 digit number that uses all 10 digits? It's simple, right? I'll simply reverse it. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we would be wrong because we cannot start a number with 0 because the place value of 0 is 0. So this number is not 10 digit number. This number is only 9 digit number. So this is not the answer. The answer would be for smallest number we have to put 1 in the maximum place value. So it will start with 1, but because I have not used 0 and zero's place value is even smaller than 1, so then I will use 0 and then I will use rest of the numbers 2, 3, 4, 5, 6, 7, 8, 9. So the smallest 10 digit number using all 10 digits is 1,23,456,789. Keep learning.
Welcome to this post-credit session on numbers. Now, if we start talking about interesting numbers, fun numbers, it will take hundreds of hours of discussion. To spare you that, we will talk only about some cool, simple facts. Let's start with Google. What is Google? Google is a number 1 followed by 100 zeros. And it is the inspiration behind the name of the company called Google. Two, number two. Number two is the only even prime number. There is no other even prime number for the simple fact that any other prime number would be divisible by 2. Zero. In ancient Roman numerals, there is no way to represent zero because Romans did not know about zero. Indian civilization invented zero and there was no concept of zero in Roman numerals. Here is one cool trick. Only one number spelled with the same number of letters as itself. It's number 4. F-O-U-R. 1, 2, 3, 4. Good question for friends. Pi. Now you are in grade 6. So you will come across pi. You will use pi a lot starting from this year and up to advanced studies. Pi is going to hold a special place and it is an irrational number. What it means is that when we write pi with a decimal point, this decimal point, it is never repeating and never ending, meaning you can go about calculating the value of pi more and more and more and more and more and more and more. I mean, it will never stop. That's what is called an irrational number, a never repeating and a never ending decimal point number. So pi is an irrational number. You will later get confused because pi will also get represented as a fraction 22 by 7. And the definition of irrational is that you cannot represent a number by fraction. Confusing, right? But we will leave this confusion for now. We will talk about it when we reach pi or some related topic. For now, remember that pi is a very, very important number in mathematics. You will find it at many places. It's an irrational number. When we represent it with decimal point and we calculate its value, it never repeats and never ends. Meaning, I can go on calculating it up to 100 places of decimals, 500 places of decimals. Just go on. Now do this for fun. What is this number? 111,111,111 multiplied by itself. Do this and you will find a very interesting number as an answer. And you know what? There was a survey conducted. I mean, some random people were asked about their favorite number. And you know what? Most of the people selected 7. I mean, what could be the reason? 7 is kind of popular. I mean, you see 7 days in a week, 7 notes in music, 7 colors in rainbow, 7 dwarfs in Snow White, and so on. So, is your favorite number as well 7?